And so I'm happy to have Christophe here, Christophe
Hi.
Thibaut. Christophe has 30 years experience in development, project management, and consulting. He's an active participant in the Paris Coding Dojo since the creation of it. He's an expert in TDD, extreme programming. He has been teaching that for 20 years. And I speak from experience because I was lucky enough to work with Thibaut when I was, with Christophe when I was in France. Oh, sorry, Christophe. When I was in France, we worked together. He introduced me to mob programming. I didn't know about mob programming, and we did mob programming together. That was amazing. And today he will talk about managing technical debt versus solving problems. How do you stop wasting your time and focus on the user? So thank you, Christophe, and you're up.
Thank you, Nicolas, for this nice introduction. So yes, thank you for inviting me to share my ideas about technical debt and the problem-solving approach. I hope these ideas will not be just my ideas for too long. So I was in the midst of a big customer problem with legacy code and not enough unit tests and a lot of refactoring required. And everybody was talking about the technical debt. And in fact, everybody is talking about technical debt. But I read a book by Billy Cohn, which is called Discussion of the Method, which is a book, the engineering method, in which he first exposed two concepts that are very simple and well known, which are the concept of a heuristic and a state of the art. So I will present quickly this concept because they change the way that I see technical debt in general and the problem we have around software development issues, be it legacy code or not so legacy code. And we all know this concept. We use them for all kind of problem solving, not only in IT, of course, but and not only in engineering, but in all parts of our life, which is the reason why Billy Cohn says we are all engineers in a way. So a heuristic is it's sometimes called a pattern, a practice, a recipe, a trick. It's a method that you use to find a solution to a problem. A heuristic doesn't guarantee a solution. It could be in contradiction with other heuristics. And its acceptance depends on the context in which you use a heuristic. And I was glad because reading this definition in the book confirmed my theory that there is no such thing as a best practice. There's always a practice in a context. And the state of the art, according to Billy Cohn, is the set of heuristics that people, well, it could be an individual, a group, or a company, or a whole society, for that matter. People use a set of heuristics together, and they call it a state of the art. So you could have, for example, the state of the art of automobile in the 20s, in the 30s, in the 50s, in the 90s, and so on. And what is characteristic of a state of the art is that you use this set of heuristic, and that is your best solution so far in face of a hardly understood problem, a problem that is not completely defined, in an uncertain situation, and above all, you have to solve it with limited resource. So here's an example of heuristic. The cursive handwriting, where we've been using that for 300 to 400 years, maybe a longer time. It's a heuristic where you use a quill and you put the quill in an ink pot and you write, and it gives birth to the cursive handwriting. And the reason the this handwriting has these long letters, is that you don't want to go too frequently to the ink pot because it's error prone. You could have blots of ink on your paper. So you have to write, you have to write in a long way, sort of. And when we invented pencils, then we could start writing in the script handwriting, where you can lift your pen the way you want, and you don't have to learn cursive handwriting still. So it's a way to show that this heuristic cursive handwriting is very bound to a context, the context of a technology, and the whole thing, ink, paper, quill, and cursive handwriting creates a SOTA, a state of the art for handwriting at a given moment in time. And it has been replaced, as we all know, by the script handwriting with pen, and of course with no writing at all because using computers. So that was an example, a very simple example. Another example is this screen of code in green is, it's a library written in C to have key value associations by the way of hash tables and linked lists. It's about 200 lines of C code. It's good. It is very good C code. It is well structured and legible. It represents the state of the art around the 80s, I would say. But of course, when you need to associate keys and values in a modern programming language, for example, in this little blue rectangle in Ruby, you could do that in 3 lines. So it's interesting because if we use the old heuristic of 40 years ago to write our own library of hash table and linked list, we could be well creating technical debt in a project today, you know, and that's an interesting case because we talked a lot about legacy code today, and maybe part of the legacy and part of the technical debt is about the context. Okay, so technical debt, you could guess that, is also a heuristic, right? It's a heuristic by which you violate temporarily your state of the art, your collection of what is best for you in your context facing your problem. You temporarily violate that in order to achieve an intermediate goal. The classical example is we have a demo 1 week from now and our app is not ready. What is not ready? Well, the persistence is not ready at all. We don't have the database and so on. Okay, can we do that with plain text file? Yes, we'll do that, but that's a hack, that's ugly. Yes, but then we will have the demo. We know that concept of contracting technical debt in order to achieve a temporary goal. So it was based on Ward Cunningham's metaphor that he did during a talk, a keynote of a talk in 2002, where he used the metaphor of complexity. Like complexity is debt. Like you skip the design, it's like borrowing money. You repay the principal when you refactor. If you don't repay the principal, well, the interest will be very expensive, okay? So I discovered technical debt, this notion, when I was browsing the Ward Cunningham's original wiki in the beginning of the year 2000. And it became quite popular. It became popular to the point of what we call now technical debt is simply bad code. It's code that is not done according to a state of the art that is never mentioned. It's always very vague. Like in this article where people say, well, we spend 300 billion a year paying down technical debt, which is bad software. And it's incredible that we are able, starting from Ward's metaphor, we are able to make it a thing, as something that we can measure and something that we can put number on. it seems incredible to me, because at the beginning it was just a metaphor. So I think like a lot of you, I don't agree with this definition of technical debt. When we see bad code, and I don't like this expression either, bad code, what we see is, for me, a solution that is being built or maintained with conflicting heuristic. So in my opinion, it's not bad per se. I don't have an absolute standard defining for me what is bad or good code, or for the customer or for the industry. What industry? There are so many industries using IT, right, and software development. I don't know. A script with 5 lines of Perl could be good code or bad code. I don't know. What I know from my experience is that when people say, oh, this code is technical debt, it's full of technical debt, what I know, what I have this intuition, and it's been verified, that this solution that they're working on is relying on conflicting heuristics. That meaning that some of the heuristics that have been used in the time and that are used today are in conflict, and there are different kinds of conflicts. So I will give examples. So the first example is an intermediate objective and a temporary conflict to our state of the art. Okay. So someone is asking, wow, that was a nice demo, but you use CSV files really? Wow, what the heck? I thought you were professional. Well, we are professional, but we had this demo 1 week from last Friday, and we weren't ready. So what we did a hack. We violated our design rules, or our technical state of the art, and so that allowed us to have the demo, which was essential at the time. But now we are back into our state of the art, and we will repair all of this. That is Walt Cunningham's original sense of contracting technical debt, right? So there's a conflict of objective, firstly, right? We have to do things properly, but we have also this demo. And if we put all our design effort into the good solution, the full-fledged solution, we will miss the demo, okay? So we contract technical debt, and we do this demo. A lot of people working with Agile, and I am one of them, say that without contracting technical debt, you cannot success in an Agile product. And this is true. And by contracting technical debt, we mean this kind of technical debt. Okay, another example. Someone is asking on a project, why did we stop reviewing code again? We were having these code reviews. They were not so great, but we could find defects and we could remove them, okay? So we have an objective. One of our objectives in our current state of the art is to find defects before our clients find them, right? And of course, we have limited resources. That's part of the context. We have a limited budget and we have a deadline, but we also have bugs. And someone decided that we have to have the solution working in production again as soon as possible. So we created this expected bug fix lane, which is another heuristic when you want something done real quick by the team, right? And you solve the problem of the current bugs in the production. And someone said, okay, well, we spent so much time on this bug fix. We went home late, and on Friday afternoon, we have this review. And someone said, no code review. We don't have time for that. So we degrade our standards, but this time we do it kind of permanently, you know? And so we are installing ourselves into a kind of technical debt because we don't do our defect removal strategy that we used to do. Okay, so that's an example of conflicting objectives that are not solved. Okay. Another one could be substitution of objective. In the last 5 years, I didn't have a customer where people said to me, you know what they did? They asked to have a proof of concept project. And once the proof of concept project was done, they asked us to deploy it into production, despite our protestation. And we had to do it. We did a proof of concept, so it was basically some play project, some toy project to try something. And when we could draw some conclusions from that study, the management asked us to deploy it into production, which is two objectives. The first objective, to try and study one aspect of a solution before deploying it, which is an objective of the heuristic proof of concept. And suddenly another objective supersedes, in a way, the first objective, which is to, well, get that in a production and see what happens. Those are different objectives. And of course, there was a conflict, and the conflict has not really been solved. Another example, well, that's my C hash table linked list library example. Someone say to a team member, wow, you wrote your own hash table linked list library. And the guy says, yeah, but it doesn't cost anything because I wrote it over the last weekend. So here, the objective might be different. Maybe this programmer knows that most programming languages have associative array, and it could be using the language associative array, but his objective is different. He wants to learn. That's the reason he used the heuristic write your own tools. That's the way you learn, right? So different objective in the same team. We often have that. Another example would be difference of context, or at least difference of perceptions of the context. The same case happens, but this time the programmers didn't know that the language toolbox had associative arrays, so he wrote his own, right? How many times did you start writing something in a new language, a language that was new for you, because you didn't know that the language had already a built-in construct to do that, okay? So it's also a difference of context. Okay, so in summary, my notion of technical debt as a tactic, meaning Walt Cunningham's original idea of technical debt, is expressed on the diagram on the graph on the left. You use this heuristic, which is part of your state of the art. It is a full part of the state of the art, and it doesn't make your state of the art for your project in this context at this time incoherent or conflictual. While what we call in general technical debt, when we say, for example, well, this legacy app is, the code base is, oh, I'm overwhelmed by the technical debt level in this, everything is bad in this code. Well, here we are in presence of conflicting heuristic that went for as long, maybe as long as went the project, okay? So you have what we call a state of the art in conflict. You have conflicting heuristic in your state of the art. So what? So what does it change to have these new notions, new definitions for the notion of technical debt? Well, this is how not to manage technical debt. Piling it, of course, we all know that. As developers, we know that piling technical debt is not good. Measuring it is absurd, because technical debt is talking about something that speaks to quality, and you cannot quantify quality. You can observe quality, you cannot quantify it. Quantifying it is like removing dimension from it and altering the meaning of what you say about quality. The worst still not happen when we quantify it. The worst is happening when we transport that to dollar value. So we talk about technical debt and we express that in dollars. Who owns these dollars? Who is paying what? I never heard a story of a developer's salary being diminished because of technical debt. Nobody will be paying that. It's not real debt, right? But the worst is not that. The worst is making a KPI out of it, like giving objective to people around the notion of technical debt. So I like this chess example because in chess we have, if you play chess, we have this notion of a gambit, which is a trade-off. On a chessboard, I could seem to be abandoning my queen, but it's a gambit. I'm giving you my queen because in the trade-off, I win something else and I will win the game. That's typically what technical debt is. So this technical debt management expert is looking for the pieces that are already in the box in this chess game, right? And he says, well, at least we have less tech debt than black because it's working for white. But it's black to play, and if you know chess a little bit, you know that white are doomed, right? So it doesn't matter the quantity of technical debt they contracted, which is less than the black quantity of technical debt, because they will lose. It's a question of strategy. So you might be asking, well, Christophe, how do you manage technical debt? Well, I would suggest to manage technical debt by examining your state of the art, meaning gathering all of your interesting practices, heuristic. I'm talking about the interesting one because there are thousands of them. The IT field is so vast, right? Then you identify conflicts in your state of the art, and then, and that's a hard part, of course, you solve the conflicts. So in my company, with some colleagues, I created the Align Your State of the Art workshop. I'm searching for a better name than this, but this will do in between the time I found a better name. So you ask people to write on sticky notes every heuristic that they use. And then you ask them to put them on the wall. And on the left of the wall, there will be the heuristic about which we don't really agree. And on the right, it will be the heuristic we all agree on. We use that and we're not going to change it. There's not much discussion about that. Maybe we should discuss about it, but we have agreement. And on the lower part is the heuristic that we didn't know that we didn't agree on, or we didn't know that we agree on. And on the higher part, on the top, is the heuristic conflict that we already talked about for some time, many times, and the heuristic that we talked about and agreed on. So in this example, on the bottom right, to give an example, I usually ask a group who indents their code, and everybody raise their arms, right? Everybody indent your code. And did you ever talk about it? No, we don't talk about it. After 1 hour of learning programming, we all indent our code. It's to expose the structure of the code. It's very useful. We could have fight about the right indentation, but we don't have fight about indenting. So we are aligned on that. We never mention it. Another example on the top right would be user story. We agreed on some user story and the user story template that we are using. It's part of a process. On the left, on the top, is the conflicting heuristic that we talk about. For example, people are asking us for quick and dirty solutions, but we want to do things better. So we have a fight between refactoring or adding features. And this fight is always going on because as we all projects are resource limited. And on the bottom left, there are conflict of heuristics that we discovered. For example, this guy said, well, if I don't have a right entry file format, it's normal that my program crashes. Garbage in, garbage out. That's my pattern. I use this heuristic. And someone else says, no, there should be a graceful exit. We should take care of our customer. So if the file format is not good, we should have a message. And those two guys are on the same project, and they don't have the same approach for dealing with format problem. So they just discovered that conflict during the workshop. So here's another example where there are mostly conflicts. So that was simplified on the last one I did. And in this one, we have a long conversation about what is part of our process that we agree on and is quite visible. We talk about it and we have even documented it. What is our culture? Our culture is what we do without thinking about it. It's our ingrained habits, the heuristic that we will naturally use, like indent the code. The problems that are surfacing on the top left, we talk about them, we try to solve them, and the risk is a new conflict that we didn't know we were having, but could be new problems. So once you do this, and it takes no more than maybe 2 or 3 hours for your average standard 6 months project with 5 developers, once you have this conversation, people start talking about those heuristics as those things on the wall, and they start to move them and to discuss about them, and they are in a good direction to begin to solve the conflict that they have. Okay, so you might say conflicts. I don't like this word. I don't like conflicts. Conflicts is waste of time. Conflicts is it could be violence even. So I want to talk about different kind of conflicts and different degrees of conflicts. So I see, in general, 3 kinds of conflicts in the workplace. There are conflict of ideas, like, for example, we decide to talk more about TDD, and we do an email reminder to people. That's an idea, to have a weekly reminder by email to our teams to do a test. But that's another idea, which would be print posters. So we have to discuss that. Shall we invest our time and energy and money into the posters or the email campaign, right? So that's a discussion of idea. And it's essential to engineering, of course, because very certainly one idea is maybe best in that context, so it should win the conflict. We have conflict of resources. Whatever you are doing right now, you have limited resources. I have never seen any project where the resources were enough from the point of view of everyone concerned with the project. So, for example, it should be, oh, there's no more paper, or there's no more ink in the printer, so we have a problem. And finally, there are interpersonal and territory conflict, which we call also drama, which is the conflicts that the kind of conflict that we want absolutely to avoid because it's a waste of time and energy. So, for example, I'm going to the printer and I see Gus at the printer, and I say to Gus, "That's funny. Each time I have a big bunch of things to print, you also have something to print too." I think I'm beginning to think you're doing that on purpose. That's typical of a drama, interpersonal conflict. And we want to avoid that. And I think this method of finding what is our state of the art and talking about it is a good way to prevent the conflict of ideas and the necessary conflict of resource to evolve in something uglier, which is territory or interpersonal conflict, right? So I see a part of my job as finding the conflict instead of avoiding conflict. I don't help groups to avoid their conflicts. I want to find the conflicts, and I mean the conflicts of ideas, because when we can talk about ideas, it's cool. We don't make it personal, as they say, okay? And there's also a different kind of conflicts. Not every conflict of ideas could be a very mutual war of ideas. You have the first degree would be indifference. This is RACI diagram of the Lord of the Ring. What is cool with RACI is that everyone knows what to do and there's no conflict of territory, right? You could have tension, like when you have an ugly code base, when you say, oh, technical debt or very bad code, and it forces you to do hack and to go to the expedit bug fix lane more often than you wish, and you're always putting out fires. And your managers, which the managers are very much not amused by the level of bugs and the deadlines that are missed, and they say hurry up, okay? And it's a potential conflict because it's a growing situation. It's escalating into a state of, well, let's say it, in a state of burnout, right? The conflict, the typical engineering conflict is a conflict of idea, which involves most of the time, but not always, a mutual exclusion. Say you decide to replace the ferry line by a bridge. You either invest in more ferries, or you invest in a bridge, but you probably won't be doing the other, the both of the solution. Sorry, except if you want to learn something, but. You have to decide the same way you would have to decide between a bridge and a tunnel, right? You have to decide if you do, I don't know, NoSQL or everything SQL, maybe not exclusively, but this is where the heuristic, where you have fun with the heuristic, you compare ideas, okay? And there is finally harmony. It's this very fragile temporary state where all the heuristics are supporting each other. And this is a drawing, I think Ken Beck did this, or maybe Ron Jeffries, about how XP practice support each other to create a great software engineering environment for developing projects, okay? So you might be wondering, do we have tools to solve these conflicts? I don't think we have that, and we don't deal enough with conflict. Well, there are a lot of tools to resolve conflict. Sprint planning, you might not be aware of it, but it's a great tool to resolve conflicts. And I'm not talking about the conflict between the product owner and the team, like in this case, where the product owner said to the team, no refactoring this week, you will have fun later, as if refactoring was having fun. This is a territory personal conflict. There could have been a very interesting idea conflict, a heuristic conflict in this sprint planning session. Sprint review, backlog grooming is a great tool for solving conversations, of course. Time boxes, maybe you're aware of it, but in a mob programming session, time box is a way to solve a conflict between two parties in the mob. Like some people are saying, hey, let's do a query on this, and some other people are saying, no, let's do an iterator on this. And someone say, let's do a time box and see what we have, okay? There are many tools that you could use to resolve conflict, and feedback also is one of them. But I would say the heuristic, we are going into communication heuristic, and I think that the best state of the art for that, and I say state of the art plural, right? Because depending on the context and on the culture, you could be using different things. Is to create an environment for collective genius to happen. The collective genius being the team, of course. So you could use, for example, nonviolent communication when you have a conflict, meaning that you would separate your feelings, how you feel, from what you think and what you want, and what you want to ask to people as a request. You could use a Toltec agreement, the core protocols like decider, ask for help, or checking. You could use clean language and the human element as well. And then you would use known heuristics to create an environment where you solve conflicts faster. Okay, I remember about a colleague. It was not a colleague. It was a friend coming to a brown bag lunch session of ours, and someone asked him, "Wow, so you said you have 20 conflicts every day. Wow, you must be really not effective." And he said, "Well, we have 20 to 30 conflicts a day, but we solve them in 5 minutes." And I think that would be the approach to solve the state-of-the-art conflicts, which leads, in my opinion, to technical debt. So that was my main idea in this talk, I guess, is don't manage technical debt. Everything agile and lean in you is crying when you stop managing technical debt. This is not a thing you have to do. Instead, you have to solve the conflict in your state of the art. That's what you have to approach. What are heuristic? What are they? Do you think we should do that? No, we should do that. Let's put that on a wall and discuss it and solve it, because we are engineers. Okay. My last advice is to read these books, the Engineering Method by Kuhn. Weinberg, of course, Becoming a Technical Leader, is a great book about communication in a team. There's a book about the core protocols, a book about a clean language, using clean language as a way of helping people getting out of drama, and Accelerate for the collection of practice. It might be the current state of the art that we use as a reference, maybe a silent reference, when we say, "Oh, this code has technical debt." I don't know. Anyway, I'm done with my talk. I hope I didn't exceed my time limit, and I'm ready for questions.
Not at all. Thank you very much, Christophe. It was very, very interesting. And yeah, we do have questions. So I think the first question I'm reading, I think there are 2 questions, so I'm trying to split them and make that reasonable for you. So the question is, in long-living projects, like 25-year support commitments, what about the tool obsolescence? For example, when you're delivering a project that was developed with tools that are no longer available. So when you're working on that project and you're discussing with non-technical people, technical debt seems like a useful concept to talk with these people, I guess, for the analogy. So what's your opinion on that?
So if I understand well, the question is, how do you talk about technical debt to people who are not in the technology?
I think that's my understanding also.
Okay, so it strikes me that we've been developing software in an industrial way for more than 60 years, right? But we use this notion of of technical debt since maybe 10 years from now, you know. And I'm one of the guys writing blogs about technical debt. Oh, you could have different forms of technical debt. And I was talking about this with my girlfriend Andrea. I was saying, that's interesting. There are nutrition facts on cereal boxes, right? So like we need nutrition facts in order to eat well. Of course not. We've been eating well for thousands of hundreds of thousands of years. We're still here, right? So you can still develop a correctly engineering piece of software without having this notion of technical debt, and without having to explain technical debt to a customer. And I swear, when I was explaining technical debt to a customer 10 years ago, everybody was looking at me with big eyes saying, "What are you talking about? We don't need that." But what would we do in the certain situation? So the customer is asking for his old COBOL system to do the feats that a full-fledged one-page application on the web is doing right now. How could we start explaining this to him? We don't have to. He knows. What he doesn't know is how to get in touch with this conflict he's having in this organization. And it might not be our role to go into that. But there's obviously an engineering conflict, right? If you have a little moped and you're pretending that you will go to the moon with that, you have a basic engineering problem. So my advice would be, how can I stop jargoning, stop using technical stuff like technical debt, and explain in very simple money, objective, and context terms where we are with the customer when he's asking this of us, right? And of course, it's a competitive field, so it's very dangerous to do that because people think, like this manager was looking for someone to manage this big rewriting program. And one very highly skilled technical manager said, it's not doable. It's not feasible. Don't do it. So what did the manager? He went in search of another guy in the company, right? So the problem here would be a communication problem, not a technical and tool problem. And I know I'm very theoretical on this right now, but you can find the words to be on the same level as your customer. And Bill reminds us of this in his book. The engineer has a duty to have a conversation with a society, with a user. He's not in his world or in our world. I hope that answers the question.
Yeah, I think that does. And you show how to use this like concept everyone is familiar with, like the heuristics, the objectives, the context, and illustrate that conflict, like bring that conversation at work, and that will be more productive than trying to manage technical debt with numbers and metrics.
Absolutely. I think the only good news for a company who creates a position of technical manager, technical debt manager, is they just gave work to somebody. It could be good, it could be not so good, But it's not effective as a way to solve the problems in the asset, in the solution.
Okay, great. Well, thank you very much. I saw in the chat that there is something froze earlier, so people didn't probably see the book name. So the whole recording will be available online, and
okay.
I will also put you the link.
Yes.
You can find with hashtag Legacy of Socrates on Twitter. You can probably find I took a bunch of screenshots, including the one with the books, if you need to find them.
Thank you for having me. It was great.
Yeah, it was really great. Thank you very much, Christophe, for your time. And now we're taking a little break. And next up will be Alexandru, who will talk about refactoring with pure functions. Thank you.
Thanks.